back to Introduction to C++. My name is Kate Gregory, and I'm introducing you to the most popular general-purpose programming language, C++. In this module, you'll really see how to build a program using loops, conditionals, those other kind of flow of control statements that essentially all programming languages have. Some of the C++ ones aren't as well known as things that are common in other languages. I have some lightning quick demos that don't really do anything useful, but they show how all these constructs work. This is also a good time to start to talk about functions, the real building blocks of just about every application. In C++, we have both free functions and member functions. I'll show you them both and show you the difference. Control is just about which lines in your program execute in what order. Normally speaking, control flows from one line to the next. Integer x equals 2, x equals 3, print something out showing the value of x, and they all just happen in that order. But just about every programming language has some way to change that around, and you should probably recognize things like if and while. You can also call a function. They're pretty simple things to get. The trick maybe is the syntax, and the C++ syntax I'll show you in working code so that you can see how it's done. And remember, as I like to say, the compiler is your friend, so that if you mess up and say leave off some brackets, you'll get an error message, then you'll know what to do about it. Things that are a little different in C++, the for loop. Not every language has a for loop, the switch statement, and the immediate if. I also want to talk about the break, which is relevant in while and for and a few other places. And I'm just going to mention that goto exists. I don't have a goto demo. I don't want you to use goto. It's there. If you happen to read it, it is a goto. But all those years ago, we said goto is considered harmful. And for those who aren't in on the joke, considered harmful has really become the nastiest insult you can give a language feature. I'm not going to show you how to use it. I don't want you to use it. It does, just for the sake of technical accuracy, does exist. That's all I want to say about goto. Let's begin with if. Like all keywords in C++, it's spelled all lowercase. And the syntax is if, round bracket, some condition, end round bracket, what to do when that condition is true. The round brackets are not optional. If you leave them out, you're going to get a syntax error. Your condition could be something like x is greater than 0, y plus 2 is greater than some function or another, any expression you like, and you can test against things that are not Boolean values. You can test against numbers, and it's quite common actually to see C++ people do that. When somebody tests against 7 or other variables that are not Booleans, they're converted to Booleans using the rules we talked about before. 0 is false, everything else is true. Go into the if or not. So for example, if x is greater than 3, y is equal to 7. You can put a line break in there if you like this. They're both exactly the same. Compiler couldn't care less. And it's important to note the compiler does not read indents and doesn't understand anything special based on whether or not you indent the lines. Those are for humans. So if you're going to have your action across multiple lines, you have to enclose it in braces. And I prefer to use them even for a single line, like this. If x is greater than 3, open brace, y is equal to 7, close brace. The reason I prefer them is simple. When you go and add a second line, you can add it in between the braces, and it'll still work. If you just add a second line when you didn't have any braces and you forget to add them, you get weird bugs because nobody complains, but the second line gets executed every single time, regardless of whether the if is true or not. So as a best practice, always have braces even when there's only a single line in your action. Now you can have an else clause if you like. It just goes immediately after the if, and it has all the same rules about single line, multiple line with braces. Best practice is to have braces. You don't have to have an else if you don't want to. If you have a lot of ifs and elses all kind of muddled up together, sometimes the compiler can match ifs up with the wrong else. Braces can help there to make it really clear what your intent is. I have a super quick demo to show you, and because I've not covered all of the C++ operators, I'm just going to keep using greater than I think it's pretty readable and obvious how greater than works, and that'll make the demo perhaps not utterly thrilling, but at least we'll just be able to focus on how if works and how else works. So let's come over into Visual C++ Express. You can see that I'm going to ask you to enter two numbers. We're going to use standard cin to get those values, and I'm not doing any error checking or validation about whether you entered numbers or letters or anything like that, because that's not the point of this particular demo. So it's not going to work right if you don't work it right. So I have a simple if x is greater than y, we'll put out that it's larger, and it has an else. And I've put braces around both clauses, even though they're only a single line, just because I feel that's the best practice. Now, a momentary word about bracing style. People have arguments about brace positioning that far exceed the arguments that they can have about politics or religion or any other major touch points. And I'm not going to go there. The bracing style I'm using is the default in Visual Studio. You can tell Visual Studio if you have a different style. So some people prefer to indent the braces so they line up here with the contents of the if. And some people like to put the first brace up here on the same line as the if. I'm not going to argue the pros and cons. There are many different bracing styles. If you're working for a company that has a style guide, follow the style guide for your bracing. If you're updating someone else's code, do not go in there and, quote, fix, unquote, that person's bracing style while you're making whatever changes you're making. For one thing, it makes diffs very difficult when you go through the source control to decide to see what was done. But also, the chances are the next person is just going to, quote, fix, unquote, it right back again. So don't get into a brace alignment war. What I'm showing you here is what Visual Studio does if you don't tell it any differently. And if you have to use a different style, get Visual Studio to help with that by changing the options so that it respects your particular bracing style. Really simple test. Here's an if with an else. And if I just scroll down a little further, I want to show you that you can have an if without an else if you want, and you also can have a single line without braces. The reason that I like to have braces no matter what is because people tend to believe that if they came here and wrote some other line like change y to 3 when the total is greater than 10, that it somehow is associated with the if, but it isn't. Only the line immediately after the if is executed just when the if is true. So this y equals 3 line would get executed every time, whether the if was true or false. And we say the compiler doesn't read indents. Since I started saying that many years ago, languages have been invented that do read indents, but C++ isn't one of them. So if you always have braces, then when you add another line, it will naturally get caught up. And this is just a mistake, and you don't want to do it. It's a pretty simple program. It's going to run. It'll print out is larger than or is not larger than. And in the case that I happen to choose two numbers that add to more than 10, it'll also print this extra piece of information. I'm going to run it a few times so that you can see. So I'll run it with Control F5. And if I enter 4 and 5, prints out 4 is not larger than 5. That's right. And 4 plus 5 is only 9, so we didn't get the extra thing about thanks for the large numbers. Let's just run it again. 6 is larger than 4. 10 is not larger than 10, so we still don't get that message. And I'll run it one more time. "55 is not larger than 66. Thanks for choosing larger numbers." So I hope no one's really surprised to learn how ifs work in C++. They work as they do in whatever other language you happen to know. And as you can see, you can have more complex expressions in your round brackets if you want them. I'm just happening to choose simple expressions because it makes the demo simple. If sends your code through one branch if the condition's true and possibly through a different one if it's false, and then life carries on as before after the if. While is for doing things over and over. So the syntax is while something or another condition holds some action. And just like if, the Round brackets are not optional. You can have braces if action is multiple lines and the like. If it's never true at all, the very first time they check, condition fails, then the stuff in the loop never happens. You're not guaranteed to have it happen once. The check is at the top. If you want to exit the loop early, there's a keyword break that does just that. So you might, for example, be going through a file looking for something. Once you've found it, there's no need to process the rest of the file. Break. Pretty simple, especially once you know if. Let me show you a demo. Flipping over to Visual Studio, I have a really simple application that asks you for a number, and I'm going to work out if it's prime or not. So I'm going to assume it's prime, and then I'm going to go through a while loop looking for factors. If I find a factor, it's not prime. If I come all the way through the while loop and didn't find a factor, it must still be prime. I'm using a different operator. I'm using less than or equal to. Hopefully everyone can recognize that. And this is a bit of a trick if you haven't done a lot of calculating of primes. It's enough to go until the number you're testing as a factor is larger than if I were to divide that number into the original number. So in the case of 102, if I would divide 51 into it, getting 2 is less than 51, so I've already tried the other half of the factor, in other words. So this is just a little optimization to make your loop go faster, and I'm really only including it so that you can again see that we can have more complex constructs in our conditions for our whiles. So what do I do each time I go through this loop? I try to figure out what the factor would be, and I'm taking something that's almost certainly not an integer and putting it into an integer. We talked about this in data types. That's going to silently truncate the result, which is exactly what I want. So if I'm testing whether or not 2 goes into 7, I'll take 7 divided by 2, get 3 in a bit. That'll get truncated out to 3. Then on the next line, I multiply it back. 3 times 2 is 6, which is not equal to 7. So in this case, this if would fail and we'd come out. When it does equal, it's because the number is actually a factor. Now we'll talk more about operators later, but I do want to show you the double equal sign being used for testing equality in C++. Something in the operators section, we'll talk more about that, just pointing it out here. So if we did find a factor, we'll print that out. Normally apps don't, but I'm trying to be transparent here and set our Boolean prime to false. Super important, if you're going to do a loop with a while, you have to do something to move you towards getting out of the loop. If you're looping while you read a file, you should read another line of the file. If you're looping while you process a data set, you should move on to the next row of the data set, and so on. Here, I'm just going to increment I. There are better ways to increment I, but those can wait for the operator's material. That's the loop. Once we come out the other end, we can test that Boolean variable prime and print out, using our newfound if skills, whether it's prime or not, and that's the whole application. So I'm going to run it. Let's test 7. 7 is prime. Okay, let's run it again. Let's test 25. 25 has a factor. Makes sense. 25 is not prime. Now, I have a little bit of an optimization in this app in that I only go up as high as I need to and not all the way until I've tested up to the value X of the number I put in. But I have an inefficiency still in place. Let's try running one more time. And this time I'll put in 12, a number that has a lot of factors. You see it finds the factor 6 and 4. It concludes that 12 is not prime. But as soon as we found the first factor, 6, we knew 12 wasn't prime. There's no need to continue to go on and find other factors. I can make this exit once it's understood that, oh, this isn't a prime number. This is a great use of the break keyword. Break gets you out of the loop you are in. So here, it doesn't get you out of ifs or anything. It gets you out of whiles, and when we do fors, it also gets you out of fors and some other constructs. So what'll happen is if we find a factor, we'll break out of the while loop, and rather than incrementing I and going back up to test again whether or not I is still less than x divided by the new I, we'll just come straight out to the line after the close brace of the while. And this just makes the code in this example a little more efficient. You wouldn't do this if you wanted to find every one, but it's common idiom to have to find the first of something, and this is a simple way to stop once you have found that first one. So I'll run it. And again, we'll do 12. This time it only finds the factor 6. It doesn't go on and find the factor of 4 because break took us out of the while. You can see that once you know if, you also really know a lot of the rules around while. Pretty straightforward. In addition to while, C++ also has the for loop. For loops are made up of 3 parts. There's the initializer that starts the beginning of the loop. So if you want to do something 10 times, you might initialize to 1 if you were going to go from 1 to 10, or to 0 if you're going to go from 0 to 9. You can declare a variable here in the initializer. If you do that, then the variable goes out of scope when the for loop is over, or you can use a variable that's already in scope and it'll continue to be in scope at the end of the loop. Next, we have a condition using exactly the same kinds of expressions you can use for if and while. That means Boolean expressions, but also things that evaluate to something other than a Boolean. And then we have the loop expression, the thing that moves you on to the next item in the loop. So in our while loop, we have to remember by hand at the bottom of the loop to put I equals I plus 1. And you'll sometimes see while loops where the increment is in the middle, especially if it's something like reading a file. The for loop expression is always done at the very last thing. So the whole loop body gets executed, and then the loop expression, and then we come around and test the condition again, and if appropriate, go and execute the loop again. So here's a sample for loop for int I equal to 0, I is less than 10, I is equal to I plus 1. And again, there's a better way to increment I, which we'll cover later. Now this loop runs from 0 to 9, 10 is not less than 10. And running from 0 to 9 is the very C++-ish way to do something 10 times. Because I has been declared right here in the initializer, after the for loop, I will be out of scope. That's great. It lets you sort of throw away these variables whenever you want. Sometimes people want to use the loop variable afterwards. In that case, you need to declare it on the line before, int I, and then for I equals 0, I is less than 10, and so on. Because for and while are so similar, I took the while example and rewrote it as a for example, so I didn't have to explain it again. Enter a number, and now I'm using a for loop. Int I equals 2. I don't need I after the loop, so I'm declaring it right there. The condition and the increment are what you recognize from the while. You're much less likely to forget to increment and accidentally write an infinite loop when you use a for loop, by the way. The body exactly the same, and we can break out of a for the same as we can break out of a while. And the printing out exactly the same. So let's run this. We'll enter a number. Let's try 25. 25 is not prime. Hopefully no one's surprised by any of these results. Let's try another one. 7 is prime. And just to demonstrate breaking out of the for loop, let's choose a number with plenty of factors. Let's try 24 this time instead of 12. First factor it finds when it's trying to, it finds 12, not prime, breaks out of the for loop. So there you go. They're not importantly different to the compiler. Okay? For and while are importantly different to people, and the ability to control that scope, to have the loop variable disappear after the loop, is a big plus for many people. They don't really want to litter their code with a bunch of different loop variables, I, J, K, and I, J, J, blah. So being able to use one like this that comes into scope and goes out of scope can be a highly useful thing. And I have a little more guidance a little later on about for versus while. Switch really solves only one problem, but it's a problem that happens a lot. It's a pattern that's super common in your applications. And that's when you basically have a whole pile of ifs because you're trying to figure out which condition you're in. So if X is 1, do something or another. If X is 2, do something or another. If X is 3, do something else. And it's a little inefficient to do it that way because the compiler would keep testing. Once you know that X is 1, it can't possibly be 2 or 3. And yet you're testing your ifs over and over. So then people write nested ifs. So they write, if X is 1, do this, else, brace bracket, if X is 2, do this, else, and you sort of nest and nest and nest. It gets really hard to read. The switch statement is just a cleaner version that people can clearly follow. Here's the syntax. Other languages have this, but the exact word that's used varies from language to language. Where the brackets and braces and whatnot also varies. So we have round brackets around the expression, just as with an if, just as with a while. Must have an open brace immediately after that and a closed one, non-optional. And then you have one or more case statements, and each one of them is case, space, some value, colon, what to do, and then a break. And optionally at the end of it all, you can have a default, colon, and what to do. If you leave the break off, control just falls down and executes the next case for you, which is sometimes what you want, usually not what you want. Then you have a close brace at the end of the whole thing to say, okay, I'm all done with the switching. You don't have to have a default, so it's not like the compiler can say, oh, I processed the default, so I must be done. It needs that to let it know. You don't put brace brackets after each case because you keep going until you hit the break. So there's no need for braces after each individual case statement. The expression you're switching on needs to work out to an integer. It's very common to switch on the value of a single variable, but it could be some expression or an enum, which are integers behind the scenes. And the individual case statements you're testing against integer values also, or enum values. I have a demo of a switch statement, and I'm sort of pulling in some other things that we've already covered to make the demos a little easier to use. So for example, it's kind of annoying to have to keep running the demo 3, 4, 5 times to show the results of 3 or 4 different paths through it. I've decided to put this loop in here. As long as you enter some positive number, you just follow this brace down. You can see that the last thing that happens in the loop is I'll ask you again for a number, we'll hit the brace bracket, and we'll come back up and do this while again. That way, with a single run, we can test a number of different values. So what's happening inside the while loop? Well, we have this switch statement. We're switching on X, which is an integral type, so that's fine. Here's the non-optional open brace and the non-optional close brace at the end of the switch statement, and everything in between is our switch. And I have a number of different cases. So case 1, that is when X is equal to 1. I'll tell you that you entered 1 and I have a break. Something you'll see quite often is 2 labels right after each other, bang, bang. So 2 and 3 are right after each other. This is deliberate, and it means that you want to do the same thing for both 2 and 3. Since we're not doing anything real, all I can say is, well, you must have entered 2 or 3. But imagine a circumstance where you process both canceled and delayed things the same way. So you might have case canceled, colon, and then immediately case delayed, and then all the code to handle delayed and canceled, whatever these are. However, sometimes people do it accidentally, so I've simulated that accidentalism here with 4 and 5. There should be a break at the end of case 4, and there isn't, and I'll show you what happens when the break is missing. And then we have the defaults. So I'm going to run this through for a whole whack of numbers, obviously. Let's do that now. So if I put in 1, it says you entered 1, that's fine. If I say 2, you entered 2 or 3, and 3 will also say you entered 2 or 3. When I say 4, it says you entered 4, you entered 5. Let's flip back to the code. Because there's no break, it fell through to the 5 case and also executed the case for 5. Probably not what I wanted. We'll try 5, try something else, and finally 0, and we're out. The switch statement certainly takes up a lot less room than many nested else ifs, and it's more efficient than just if testing the same thing over and over again. After all, once we've established that x is 1, there's no way that it's 4. Also, stacking these up like this is more readable than combining them with OR. You haven't seen combining with OR yet, but trust me, this is more readable. So for certain kinds of architecture of your application, the switch statement is really useful. In modern C++, there are some alternatives, especially when you're working with objects and you have hierarchies. You can, rather than switching on something, you can have your objects be of different type and have an implementation of a virtual function in that type handle whatever this is. So you may not see as much switch statements, but when you see them, I want you to be able to read them, and I certainly don't want you writing big, long, nested else ifs when you could have just used a switch.